Okay, here we go. Problem number 31 from section 4.4. Problem A. A rectangular sheet 36 inches in perimeter with dimensions x and y can be rolled into a cylinder. What are the values of x and y that give the largest volume? Well, first of all, let's talk about, we know we have x and y. Is there a...
There's no top and bottom.
No, I'm not worried about the top and bottom. What I'm saying, is there a function, is there an equation that will tie x and y together? Right? We usually call this the relationship equation. Yes, Adam?
2x plus 2y equals 36.
2x plus 2y equals 36 because these represent the four sides and the perimeter is 36. Great. Now, is this the function that we want to maximize? No. The function that we want to maximize is the volume. And how do we find the volume of a cylinder? It's pi r squared, which is going to be the area of the base, multiplied by the height. But in this case, the height is y. And do we know what r is? Well, we know that the circumference is x. So let's do a little thing. Circumference is x, and circumference is 2 pi r.
Yes.
So circumference is x, and if we solve for r, we get x is pi over 2. So we're going to get volume is equal to pi times x over 2 pi, quantity squared y. And that's volume. Now, we don't like this volume equation on a couple different counts.
X equals 18 minus 1.
One, because it has two variables in it. It would like to get rid of one of the variables. It looks like y would be the better variable to get rid of. Okay, so if we take our relationship equation, and as Aaron had recommended, solve for y, you get y is 18 minus x. So our redone equation is going to be pi, I might as well expand that, x squared over 4 pi squared multiplied by 18 minus x. Clean that up a little bit more, I get x squared over 4 pi times 18 minus x. Oh, I suppose I can distribute that as well and get 18x squared.
Actually, if you're solving for zeros, can't you just do it now?
Well, I got to remember, this is the volume equation. What I'm going to need is v prime. I'm going to need the derivative.
Oh, okay.
And so what I'm doing
Yeah.
is hopefully going to make taking the derivative a little bit easier.
Yeah. Sorry, I forgot.
How about 9x squared over pi,
X cubed over 4 pi.
over 2 pi?
Wouldn't it be x cubed over
X
4
cubed
pi?
over 4 pi. Still.
Isn't it over 4 pi still?
Well, I took the 18 and I took out 1
No, like on the other side.
Oh,
X cubed over 4 pi.
over 4 pi. Yeah, I don't know if I made it any better or not. But let's take the derivative of it regardless. V prime is going to be 9x over pi minus 4x squared over 4 pi. Well, I took the 2 down. I brought this 2 down, and there's a 2 in the bottom. They canceled.
So you're treating 1 over 2 pi as a constant, so you don't have to hit the problem.
Yeah, pi is a constant, 2 is a constant. I don't know. Is that right?
That's not so bad. That's not so bad.
You're okay? Is it okay? All right.
Then you put them on
And we
opposite sides.
And now we got to set that equal to 0. I got a great idea. Let's factor an x out.
That's a great idea.
That gives us 9 pi minus 3x over 4 pi.
So we know that x can't equal 0. Or
So
well,
x equals 0 is a value that makes the derivative equal 0, but I can't imagine that maximizes the volume. In fact, I would say that minimizes the volume.
It's not on our, really on our.
It's not in the domain of X. All right. So that, although that's a solution, sorry, while it makes the derivative equal 0, it really doesn't help us. When we set this equal to 0, we get 9 pi minus 3 pi over 4 pi equal to 0.
You're going to hit you with that high.
9 pi is equal to 3x over 4 pi. If I multiply both sides by pi's, the pi's go away. And if I do the rest of the cross multiplication, I get 36 divided, I get, I think, 12 for x. And if x is 12, that means y is going to have to be 6 based on that equation. All right. So part A is done. Great.
Yeah.
This was decent.
All right, are we good there? Because now we got to do part B. And I want to erase this before I go on. We good? Okay. So here we go. Let's do part B. In part B, we're going to take that same sheet and we're going to revolve it. Now, what do I mean by revolving it? It means that as the center is kept in a single place, this sheet of paper would sweep through a volume. It sweeps through a whole thing and would be considered making a cylinder. Now, of course, if you were in Calculus AB last year, you know all about volumes of revolution. We don't have to talk about that right now, but it makes a cylinder, okay? And that cylinder is the cylinder is going to have a height y and a radius x. So in problem B, volume is going to be pi r squared h, and in this case r is x, and height is y.
Why do you have a 2 instead of pi?
I don't know.
We should have.
You're all over the place with your paperwork.
Why'd you put the 2 in? What's going on? What's happening?
Pi r squared h, pi x squared y, and we still know that y is equal to 18 minus x. Is that correct?
Yep.
So we have those facts together. So volume is going to be pi x squared times x, 18 minus x, pi 18 pi x squared minus pi x cubed. And now we're ready for the derivative part of the show. 36 pi x minus 3 pi x squared. And I'm going to set that equal to 0. Factor out 3 pi x. And we're left with 12 minus x. Is that right?
Yes.
Yep. Okay, which means that x equals 0 is a critical value. I don't think it's going to maximize anything. And then x equals 12. X equals 12. And its counterpart y equals 6. All right? Now, coincidence?
No. There are no coincidences. Only crazy random happens.
But I think that's it. I think that's it.
Yay.
All right, there's 31.